Hello, in this video we're going to look at what we call integrated rate laws, which is an absolutely terrible phrase, but essentially it is how concentration changes with time. So you might want to run a reaction and say, how long does it take for the concentration to get to, zero point 0.1 moles per liter? Or if I start with 10 moles per liter, how long will it take to get to 1 mole per liter? Or, interestingly enough, if I measure this concentration from a reaction, how long did it take to get there? So if you carbon-14 date, right, you can actually predict how long ago something died from using the ideas we're going to generate in this section of the course. So let's go ahead and dive into it. So essentially what we're trying to do is figure out how concentration varies with time. And it turns out it depends upon the rate law. So it depends upon the kind of the rate law you have. And it's actually kind of complicated. And so we're going to go ahead and look at just 3 different situations. We're going to look at a first order rate law, and we're going to look at a second order rate law, and just for fun we're going to look at a 0th order rate law. So we're just going to look at these 3 situations here. And what do I mean by a first order rate law? Well, imagine you've got a reaction, so you've got A turning into product. So I'll just write A goes to P. If it's first order, what I mean is that the rate is equal to K times by A to the first power. And if it's second order, that is telling me the rate law is K times by A to the second power. And if it's 0 order, I can write it as K times by A to the 0. And and that's just the same thing as writing just K. So the concentration of A has no effect at all upon the rate. So we're going to go ahead and we're going to figure out how the concentration changes with time for these 3 different situations. And I'm going to come back to what I started off with, the integrated part of the title here, because it turns out that this is actually calculus. So the rate law is actually a differential equation, and to solve it we're going to actually reverse differentiate, which is called integration. So if you're a calculus geek, this is pretty awesome stuff, but otherwise it's really just trying to figure out how concentration changes with time. So let's go ahead and look at this in a second video.